Okay, hi guys. We're going to get started with lesson 4, and so I would like you to have handy your notes from the King Henry story. Have that right in front of you so you can see the place value chart, okay? Because we're going to be talking about it constantly. All right, so this is about converting and writing an equation with an exponent. So I don't have any meter strips with you because you're all at home, but we're going to follow this example. So if I have a large unit, okay, and I want to change it to a smaller unit, and we're not just talking about like 1 meter, we're talking about 3 meters. And we're going to change it into smaller units. So we're not changing the length of 3 meters. We're just going to call it a different label. So 3 meters is equal to 300 centimeters because, of course, 1 meter is equal to 100 centimeters. Remember, it's always nice to know how many are in 1. And so then you take this apart and you have your 3 because that's how many meters you have. And you have your 10 squared because you're changing 2 place value positions from meters here in the units to centimeters, which is 2 positions over. And this is equivalent to a skip of 100 2 place value positions, right? And we're going to label this because they didn't label it for us, but we're going to label it like it is right here. So the idea is that you have to figure out, first of all, what operation are we using? If we go from a larger unit to a smaller unit, you're going to have to multiply because we have a lot more of the smaller amount, okay? Now this one, right off the bat, notice they switch it. Now we have smaller to larger. So it's like, oh, if I had to multiply here, then I have to do the opposite here. I'm going to divide. So we have 105. Now you might be thinking, well, if 1 meter equals 100 centimeters and I have 105 centimeters, well, it's just a little bit over 1 meter. So how would that look? So you're going to take this number, your 105, and we're going to use division because, again, we're going from a smaller unit to a larger. Okay, so we need to end up with less of the larger unit. And how many positions are we switching? Okay, it's the same number of positions that we had last time. It's 2. And so you're still going to use 10 squared because it's a 2 position shift. Last time we went from meters to centimeters. This time we're going from centimeters to meters. So that's the 2 positions. You can call it 100 or you can call it 10 squared. That's the same amount. And then you set it up to solve. And so if, like in lessons 1 and 2, we have 105 divided by 10 squared or 100, that's a 2 position shift. So this big number here is going to shift 2 places to the right, smaller place value positions. And for those of you who are thinking, well, I have this decimal here. If I move that left 2 positions, I get the same answer, and you would be right. And of course, we're going to label it because we need to show that 105 centimeters is just a little bit over 1 meter, 1.05. Okay, so that's kind of the goal of today. We're going to use exponents to denote the powers of 10 with the application to the metric conversions. That's our objective for today. So let's take another one and think about how to apply the same rules. I'm going to skip this one because it already has meters to centimeters. So we know that's going to be using the 10 squared. Okay. And let's go, this one already has one that's over 1 meter. So let's go to less than a meter, 80 centimeters. Now I'm going to have a small unit to a large unit. So when I have a small unit to a large unit, I'm going to use division. Okay. Now what do I have here? I have 80. And so I'm going to take my 80, and I need to use division because I'm going from a small unit to a larger. And we're using this centimeters to meters 10 squared again because it's a 2-position shift, 2 positions. And we're going to shift this 80 to smaller place value positions, okay? And if this is where the decimal was, we're going to have a 2-position shift. 1, 2. So we're going to end up with less than 1 whole of meter. So it's really just kind of keeping the numbers the same. As you might notice here, it's a pattern. And we're going to label it with the new label. Okay? So let's do another one so you can see how much it just follows this pattern. Let's go from a big one to a small one again. So meters to centimeters, a large unit to a smaller. We're going to use multiplication for our operation. And we're going to take that 9.2 and we're going to multiply again. And how many positions are we changing? It's still 2, so that's going to be 10 squared because we're using our exponent. But this time we're going to multiply, so we're going to take the 9.2 and we're going to shift it. Now if 9 in the ones place has to move to the left to become greater, and again the value of this is 100, right? So 9 ones has to become 100 times greater. So you take the 9 and the 2 and you go shift, shift. So 9 would then be in the hundreds place, and your new unit would be centimeters. So I hope you understand. I hope you can see how it's just kind of a pattern. Let's do another one real quick. And if I have centimeters to meters, I'm going from a small unit to a large. This is a very, very tiny amount, okay? And I need to figure out, well, how much of this big, huge meter stick is 4 centimeters? It's a very tiny amount, okay? Now again, when you are going from a small unit to a large unit, you're going to be dividing, okay? So use your division, and then it's a 2-position shift. 2-position shift is 10 squared. And if 4 is in the ones place, but it has to shift 2 positions smaller or lower, it would shift to the tenths, then the hundredths. And so really that makes perfect sense because 0.04 would go here. Because if you're looking at a meter, which is a big, long, like a yardstick, but a little bit longer, okay? If you're looking at a meter stick and you have 4 centimeters, that's only about this much, okay? Right here, 1, 2, 3, 4. So that's a very short amount out of a big, long meter stick, okay? So now let's take a quick look at G. And it says in the space below, list the letters of the problems where larger units are converted to smaller. So you want to look, this is where we were pointing it out. Why is it important? Well, you have to know what operation to use. So larger to smaller, that's A. This is smaller to larger, so no. Larger to smaller, C. Smaller to larger. Larger to smaller, E. Smaller to larger. So A, C, and E are the problems that have this larger units converted to smaller units, okay? Now at the bottom, it's the same approach with an exponent. The only difference is that instead of going from meters here in the units column to centimeters, which is 2 positions away, we're going 1, 2, 3 positions away. And we're talking about the millimeters, the super tiny ones, okay? So you can see as we go from meters to millimeters and millimeters to meters, it's a lot of M's, but we're just trying to do the same thing. The only difference is that we're going to be using 10 cubed. 10 cubed. So let's do a couple of problems. Actually, I'm going to stop and I'll start another video with the bottom, and then I'll do a separate video with the back side. That way it won't take too long.